Hello and welcome to Shapes 2. This video will be a special kind of video off topic from my current playthrough on Shapes 2. This video will be some kind of tutorial or explanation on how to use wires. Wires are a crucial element in Shapes 2. You need it for your MaM, but it can also have other purposes for your needs. What are wires? Well, wires you need to buy the upgrades first. You see that on the right side, if you have enough points and what is it called? Research points, yes, you can buy 4 upgrades that's about wires. Mainly the wire basics, logic gates, simulated buildings and global wire transmission. Wire basics contain the basic stuff about wires, like of course the wire itself, signals, filters, readers, displays and buttons. And then you have logic gates, which are buildings that compare signals with each other. Simulated buildings simulate real buildings but then on a wire level, and then global wire transmission are buildings that you will use these for your MaM, for instance. These are buildings that, you know, the name speaks for itself. They transmit globally signals. Yeah. Once you unlock all these categories, you can find everything in the wires category. Next to the shape processing and fluid buildings, we have a lightning bolt called wires. In this category, you have 2, 4, 6, 7 subcategories or items. You have a wire, display, signal producer, flow control button, logic gates and simulated buildings. I placed all these buildings on this platform already, and I'm gonna go one by one explaining them, what the purpose is, an example, a real world example, because I have my MaM in this game also, and I might perhaps refer to a building in this build, which possibly makes it understand it easier. Our first category is wire. We have 6 buildings in this, actually 5, but yeah, actually 4. Some buildings are reusable and reusing other buildings and whatnot. The first thing you will need the most is a wire. Compared to Shapes 1, a wire is now a physical 3D object. Of course, Shapes 2 is all 3D. What is a wire? Well, it transmits signals. What is a signal? A signal is some variable. It can be a color, it can be a number, it can be a shape code, like anything that the game can recognize. You can use wires on both of the 3 levels, which is a good thing. Mostly I do it like this, if I need to transmit signals to multiple levels. And there are some limits and constraints to how you can, you know, build signals. If I remember correct, you can't have a T intersection. For example, if you go up here, it doesn't allow it. The same with, for example, if you do this and then you want to do that, doesn't work either, or above, doesn't work either. So there are some Annoying, if I'm saying so myself, there are some annoying things about wires, but it gets the job done. That's basically the most important thing. The second thing you have is a wire bridge. This just is a building that exists of two wires overlapping one another. If you would do this manually, you would need to actually raise the second level and then go over it, like so. But this is not necessary if you use the wire bridge. The wire bridge is also usable on 3 levels, so you can. I rarely use them, but you can do something like, I don't know, something like this would work. Yeah, it allows you for flexibility and more space. That's the purpose of the wire bridge. The next building is a wire transmitter. This sends a signal over a distance, and in this case over the distance is 4 squares or grids. Like 1, 2, 3, 4. This building is pretty self-explanatory. It just, you need a signal to send to, and then it receives it on the other side, and it sends the signal through, and that's basically it. They are particularly useful in use cases where you want to send a wire over belts. For example here. So you want to send a signal to the other side, you do it like so. Easy. They also use multiple levels, so you can easily do this, send the same signal on 3 levels using wire transmitters. But this is a bit, it's not even needed to do that like that, because the wires can already do 3 levels itself. Yeah, so that's basically it for that building. That's self-explanatory. The other building is the same building, but you start receiving. As you can see, my mouse is on the receiver part and not the transmit part. See, this is the transmit part and this is the receiver part. That's the only difference between that. Then you have the global wire transmitters. This is a building you will use when making your MaM. What is a MaM? It is a make any machine, which is practically a build you do, and it automatically builds a shape for you using signals. In Shapez 1 you did not have these, if I remember correctly, but in Shapez 2 you do. This is of course really helpful, because nobody wants to route a signal from miles away. For example, I don't know, let's say something from, you create a signal in this grid, I want to send it all the way to your MaM. So you're not gonna, spend the time building foundations and so on with only a wire routing the signal from A to B. No, that's not how you do it. That's why you have these global transmitters and receivers. A transmitter can hold 8 signals. So it's kind of some memory saving building. You set the signal on a channel and then you receive the same channel which receives that signal that you've set. For example, I have now channel 7 selected in colored. If I want to create a signal, and more on that later, you use the signal producer and I configure it to send 33. Okay, good. The signal is entering the global wire transmitter on channel 7, and then somewhere else in the world, in the game, you can here random platform, you pick the receiver because you want to receive the signal you've set. You select the channel you want to receive, in this instance channel 7. You attach a display to it to know, just to show you that it works. And indeed it does, it shows 33. If I go back and send something else, for example a shape or a color magenta, well, what does it receive? The color magenta. And you don't have to edit anything, everything is automatically being done for you. This is just like programming. And again, I'm gonna last example to send a shape. So any shape code, it can be 1 layer, 2 layers, 3 layers, 4 layers, or I think in the hex mode you can have 5 layers. I'm gonna get an example shape from here. Oh, nope, that's a blueprint. That's a blueprint code. There you go. You're gonna say, I want to set this signal. Boom, you go back to the receiver and it sends this exact signal back. The global wire receiver has 2 special channels. Let me show you again. The transmitter has 8 channels from 0 to 7, but the receiver has 9. As you can see, it receives the random operator shape also. So instead of going to operator tab, oh, I want this shape, you want the color, I want to send, not the color, the shape, I want to send the shape to a transmitter, you set it, okay, fine. And then you go back to your receiver and okay, sure, you have the shape, it works. But would you do that every time you level up? No. That's not the purpose of a MaM. A MaM is something you don't interfere with. You let the game run and you let it make shapes au volonté. Which is why this comes into place. So if I want to, instead of, and I lost the coordinates. Where did I, oh no. I want to get operator shape 0. There you go. It's of course the same. But let's say I want now shape 1. There you go. And every time you click on, I don't remember exactly what it was, level up or something, or continue or complete, whatever, the signal gets changed also with the next level of shape you need to get. When making a MaM, this is the only manual action you need to do, which hopefully, perhaps, maybe in the future gets solved. That for randomized goals, the button is automatically clicked or something, so the MaM can work fully uninterrupted. So that's it for the first category of wire. If you have any questions, please feel free to ask the question in the comments, and I will help, of course. The second building is a display. This is simple, you've seen me use it already. A display is basically, it reads the signal from the wire and it displays it. That's it. There's nothing special about it. Sometimes, okay, maybe because the game supports like null signals and whatnot, or 0, if I remember correctly, a null signal equals a black display. I'm just gonna test it right now. It's already set null. You connect it and it's black. If I zoom in, I do see, no, it doesn't. I thought I saw a visual change. The display can display any logical signal, if it's a color, a number, null, a shape, it does it all. A signal producer, you've seen it also some seconds ago. This is a building where you choose yourself what signal it produces. You configure it and you enter the signal you want. As you can see here are the valid options: null, conflict, a number, a fluid, aka a color, or a shape code. I've never used conflict before. It's not, a conflict is a bad thing. I wouldn't understand why you would check it or produce it, that signal, but it's there, you can use it, whatever. How does it even look like, a conflict? An exclamation mark, okay, that seems fair. Null shows literally the characters null. A number is also just the number. The color visually shows it on the building, just like the display. Yeah. So you have white, magenta, and so on, the 7 colors. Or a shape code. Of course, it copied the. God damn it. Let's do a star, magenta, a rectangle, uncolored, not star, spike. Then a windmill, not a windmill, it basically doesn't exist anymore. But the code still does. White, And the circle, for example, blue. There. That's it, that's the building. Now the cool stuff comes. After the wire category, the display and the signal producer, you arrive. These are buildings you will use in your MaM, and I will also show it soon how I use it. First, you have a belt reader. What does it do? It reads belt. It reads two things. It reads what's on the belt and the speed. But the signal you get from it is only the shape. Let me show you. This is the speed. The number you see is the speed, 180 per minute. But the signal you get is the shape on the belt and not the speed. Keep that in mind. If suddenly there is no shape anymore, it goes black, which means, as you know, it is null. Null means nothing. I can't give you a real world example because I'm actually not using belt readers for my MaM. The next is filters. Of course, I use these all over in my MaM. This building filters belts. It allows one input of a signal. It can be a number or a shape code. I have to think if I'm correct. Let's say I want to filter this belt, of course all the way around, because for clarity, space it a bit outwards. If you check the UI, it says the cross to the left and a check mark is straightforward. Let me start with an example. Let's say you only want circles on this belt. Well, pretty simple. Let's use a signal producer and enter a one layer circle, all uncolored. What does it do? It goes to the left because it doesn't satisfy the signal. It's not true. This is just like programming. This is basically an if statement where you say if this shape is the same as the signal, go through, if not, it goes to the left. Let's do another example. Let's say I have squares here uncolored. Let's use a belt reader. I'm gonna forward the signal to here. Remember, it reads the shape of the belt. For debug purposes, or if you don't remember, you can always use a display to see what's on the signal or on the wire. Let's say you want these shapes to go through if this signal is a square, uncolored. Then you can just connect these together and it will go to the left because they're of course not uncolored squares. But let me cut this off What does it do? Nothing, because it's null. A null is something that can be checked. You would need to manually use a logic gate to do so, and then I think later on we will do that instead. But this is a way to filter out belts. Let me go to a real world example, to my MaM. This section here does, I have it written here, does the lower left quarter of the top layer. And here I have a filter. It reads the signal and it gets the top layer, you know, that quarter from the top layer, and it checks if it is the right quarter. That signal gets sent to the belt filters, and if it's not the right quarter, it goes to the trash. If it is the right quarter, it goes through. These kind of filters are everywhere in my MaM, because you need to flush out a lot of shapes to efficient, you know, build the next shape as quick as possible. So for example, I have a check for every quarter, but I also have then a garbage collector filter on every layer too. This cyan channel reads the first layer. Well, if it's not the right 4 quarters, it throws it in the trash. If it is right, then it goes through. And again at the end, it checks again. It's the same thing, because this is a very long belt, and so shapes will get filtered out at the start of the belt and also at the end. As you can see, the first layer is 3 quarters uncolored and 1 quarter is yellow, and this satisfies the filter, so it goes through. And then at the end of my MaM, there's again a filter slash garbage collector that checks the full operator shape. Next building has the same purpose but for colors. This is recently added in the 0.0.8 update. The only difference it has is with throughput, whereas the belt filter one belt filter can be used for one belt, but not in the case for a pipe gate. For one pipe you need 4 pipe gates to have 100% full efficiency. Let me go straight to, well, let's test it somewhere here. So you connect it to the pipe, and just like the belt filters, you can attach a signal to it to allow if the paint goes through or not. For example, okay, sure, if the color is blue, you can go through. Oh, it doesn't. You can go through if the color is red. Oh, it goes through, that's perfect, that's what we want. But a bit more advanced. Let's say, okay, if there is shapes on this belt you can go through, well, you can just use the belt reader and connect it straight to this pipe, and you will see it goes through. If it stops, of course I have to clear it, it doesn't go through. You have plenty of possibilities to send a signal to this pipe gate, but as I said, you need 4 of them, so you would need to do something like this. But then, yeah, let me just go through my MaM and show you I actually don't use it. I do have a blueprint that I can show you. This is a platform that can filter 7 colors and output one of them based on the signal. So as you can see, 1, 2, 3, 4, 5, 6, 7. You input all the colors in here. You set the signal, for this example red, and then only red goes to here, to the output. And this does happen with pipe gates. As you can see, I have 3 levels full of them, and each have 4 pipe gates, because I say 4 pipe gates because the fluid throughput is 1800 liters per minute, and a full pipe can do 7200. So you just, divide that. Oh, a small tip, you can use the console command calc and just do like a quick calculator. So let's say, you don't want to calculate how many pipe gates you need. Well, you just you press F1, you type calc, and then the expression or the calculation you want to do. For this example, so 7200 divided by 1800, and you press enter, and the result is 4. Great, right? Okay, let's go back. So that is pipe gates. The next building. Well, it's a simple button. What does it do? Well, it goes on and off. But you have to do it manually. So, let's say I want to manually open this pipe gate. Well, toggle. There you go. And you toggle it off to make it stop. Simple. You can also connect these to the filter, of course. Go through, don't go through, go through. This doesn't make sense though. I feel like if you toggle, okay, sure, one side of the toggle is true, but the other side should be false, so it should be actually go to the left, but it doesn't. I guess it does. We can check it ourselves. What signal does it give? If it's on, it returns a 1, and if it's off, it returns 0, just as I expected. But technically it should be 0, but it is what it is. Okay, now the important stuff, logic gates. These are buildings that compare signals with each other. Haha, Now the fun begins. And the complexity. First building, the ant. The description says activates if both inputs are on. I want this shape to go through if this belt and this belt is, is fully saturated. If you want to do something like that, you can use the AND gate. You connect the input signals, which you want to check from. So you do a belt reader from this, and a belt reader to here. There you go. Both belts are moving, both belts are true or have a shape in their signal. And a shape in a signal also means true. But the AND gate only returns 0 or 1s. So for this instance, both signals are sending and exists, so it returns a 1. If one belt stops, it's 0. If two belts stops, it's still 0. Because it's an AND. Both signals need to satisfy true. And then only, but only then, the AND gate will return a 1. So now I can connect to this. Here we go. These two belts are moving, so the third one is also. Again, if I stop one of them, this one goes to the other side because it's a 0, as you can see. If I interrupt the other signal, it still returns 0. If I undo both of these, it will return to a 1. There you go. What other signals does it accept? Well, let's see. What is interpreted as a true signal? A 5 and a 5 or a 6. This returns also a 1. A shape, a color green, and number 5. They both are true, so it returns a 1. From the moment you enter null, it says null. There's a difference between null and null. Yeah, you know. If I change it back to a star, and it's saying it goes back to the 1. If I do a conflict and a shape, it returns also 0. So from the moment one signal is 0 or null, the AND gate will return a 0. Next building, the OR. Same purpose like the AND gate, but now only one input can be activated. I mean, can be. Why is this so hard to explain? The OR gate activates if either input is on, so it doesn't matter which one. Let's do it again with our two belts. Let's do a display. Both signals have, no, both wires have a signal. The shape from each belt. So what does it return? It returns 1. But here's the difference between the AND gate. With the AND gate, what did happen when one belt was stopped? It returned 0, but this time it doesn't, because it's an OR. Basically, you're checking if this belt is running or this belt is running. I'm satisfied. You can return a 1. But if I do both, then it's finally a 0, because nothing is true. There's no shape, there's no color from any wire, so it returns 0. The 0 is here, so it goes to the right. If I now undo one belt, then it goes straight, because the OR gate returns 1, and because one signal of the two is satisfied. If I undo this one, nothing will change, because there is already one signal that is on. Okay. You can also do this with belts. I mean, not belts. With pipe gates. Right? Let's say, oh, I don't want to. Let's stop both of them. There we go. It returns 0. So the paint is not going through. If I put one signal on, then it goes through. There you go. And again, the second belt doesn't matter because one of them is already on, and that's how the OR gate works. The NOT gate. Haha, what does it do? Well, it activates if the input is off. So, in other words, it changes the signal to the other state, if you know what I mean. The opposite of the signal you've sent. That's what I wanted to say. The NOT gate is the opposite of the signal you've sent in 1 or zeros. If I say, okay, a 1, it becomes a 0. If I do a 0, it becomes a 1. If I do a color, guess what happens? the T doesn't exist, bro. The white, it returns 0. If I do a shape, it returns 0. Basically, like I said, it's the opposite of the signal you sent. We know every signal returns 1 when using the AND or gates. Well, it does the same here. As input, the NOT gate translates the shape in a 1, so it returns the opposite, the 0. Another example, let's say, okay, if this belt is doing something, if there's shapes on the belt, then this belt needs to go to the right. It's the opposite. If you interrupt this belt, it goes to 1 and it goes straight. Pretty useful, right? If I undo it, it goes back to 0. There's a signal on channel red, so it returns 0. There is nothing on channel 6. Okay, it does now, because... Wait, what? There is nothing on channel 5, so it does the opposite. It does return something. Mainly number 1, or true, the XOR. I have never used this one. Let's find out together. The XOR the XOR gate activates if exactly one input is on. This does remind me of the OR gate. This activates if either input is on. But the XOR gate activates if exactly one input is on. So okay, let's find out the difference, because in my ears it sounds the same. We have the belt running. The belt reader is returning 180 and it is reading the shape from the belt. Both buildings return a 1. If I interrupt this, both return also a 0. So far, so same. Let's do a second signal. Oh, there you have it. There's a difference. The XOR gate, like it says, only activates if one input is on. If one input is on. You see, this belt is on, so it returns 1. 2 belts are on, it returns 0. Both belts are 0, it returns 0. And the difference between an OR gate is that an OR gate can have 2 wires with an on signal, whereas the XOR gate doesn't allow it. Then we have the equal, the comparison, which I use in my MaM. this is a more complicated button, for example. But with the comparison building, you have more options. So this building activates if both inputs match the configured comparison. You can choose which comparison it does. Equal, greater, greater or equal, greater, less, less or equal, or not equal. Let's try it out. Let's say equal. Null equals null, that's true, so it returns 1. Null equals null is not true, it returns 0. A color red equals null, that's not true, it returns 0, yeah, and so on. Until you match both signals. Color red equals color red, yeah, that's true, so it returns 1. If you want the opposite, just like, you know, the NOT gate, the opposite. This is the opposite of the opposite. Okay, yeah, no, I'm not gonna continue that. Simply color red. Does color red not equal color red? Well, it does. So that's false. This comparison is not true, so it returns 0. And then here we're doing the opposite of 0, which is 1. Let's compare it to color white. Same thing. Does color red not equal color white? Yep, it does, so it returns 1. And the NOT gate returns 0. What else do we have? Greater equal, greater, less, less equal. These are comparisons which you would use for numbers. Oh, is 69 less than 100? Yes, it is. Yes, 69 greater than 100. No, it's not. Is it greater than equal than 100? No, it's not. Is 69 greater equal than 69? Yes, it is. But is it greater? No, it's not. See, these are comparisons for numbers, and as far as I know, you will never use these. The greater equal, greater, less, and less equal, you don't. There's nowhere you get a signal which is a number from any building unless you configure it yourself in a global wire transmitter or in a signal producer. In my MaM I also have some comparisons here. This is a platform that checks quarters. As I said, this produces a quarter and this also. So in here you get 2 quarters. But what if 1 quarter is null? Because mostly I want to combine them, but that's not the case when 1 quarter doesn't exist. Well, here's that comparison. In this instance, so this side receives this quarter, but the signal is a check from this quarter, of course, because you want to check if this signal can be stacked with this quarter, and vice versa. So in this case, channel 3 has a shape which is layer 4, if I remember. Yes, it's layer 4. Then you rotate it a few times to check the quarters. Well, it's all circles, so if one would be empty, one signal would be null. This signal would be null. I would compare the signal. Oh, if it's null, then sure, go through. No, it's actually not equal. I've set the comparison to not equal. So if the quarter from the other side is null and you compare it, if it's not null, so then it returns 0 because it is null, so it goes to the right and it skips the stacker. That's basically it. The same happens with this side. If this signal is null, is it not null, then it goes through because it needs to be stacked with the other one. If it is, then it goes a bypass and it goes through, and that's basically it. Here I am checking. This is an OR gate actually. This side receives the 2 top layers, so these 2. The other side receives the bottom 2 layers, so the square and the bottom one. And here I say, so these are the 4 layers. If one of these layers exists, you can go forward. If there are no layers, you can bypass the stacker again and continue. For example, if we have a shape that has only 2 layers, only these or these, I don't remember exactly, will return 1, or actually 0. The last building of the subcategory is a gate, a normal gate. What does this do? Well, it forwards the input signal if the trigger signal is on. This is some sort of bypass. Let's say you have a signal coming through. It doesn't matter which one. Doesn't matter which one. Okay? Display. Okay. This is the return signal. For now nothing, because we need to set this signal. This signal can be 0, null, a color, a shape, anything. So if I would connect this, what would it do? It forwards the bottom signal to up. Yeah, capiche? If it's suddenly no signal, it stops sending the bottom signal. What's the purpose of this? Well, let me give you an example again. This can be a complicated one. So I'm reading this belt. It returns this shape, as you can see here. But I'm not allowing the signal to pass through to this belt to, for example, filter. If I would let's combine these belts. Let's use a button. There we go. I want the signal to pass through, toggle, and in the meanwhile I'm filtering out only these shapes. The uncolored squares go to the right and the shapes I want go to the, go straight. If I don't want to filter anymore, toggle it off. If I want to set another filter, now I want squares on this belt. You turn it on, the filter is set, and now it only allows uncolored squares. Cool, right? You can do the same with the color. Oh, sure, if this belt... Wait, what would it do? Now I'm curious. The signal is this shape, right? But this is a pipe without shapes. So we're filtering this pipe to only allow shapes, huh? Let's see what it does. There's my button. On. Yeah, it does nothing. Well, because it's not the shape, of course. The last category are buildings that simulate real buildings. Straightforward, but they only work on a signal and not on a belt, for example. I have here some simulated buildings that get used for testing. This is actually testing, but it's the same thing you would do if you would make a MaM and make any machine. Like here, this is my MaM logic. So let's first go back to here and explain some of the simulated buildings. So we have our input. This is a signal producer. I've set the shape myself to this shape. It is a 3-layer with spikes on the top. In the middle there's diamond shapes, and on the bottom it's like that, with each their color. The first building the signal enters is a simulated unstacker. This simulated unstacker does not exist as a real building. There are two simulated buildings that do not exist as a real building: the unstacker and the shape analyzer. What does the unstacker do? Well, it separates layers. As I told you, this shape has 3 layers. So for my MaM, I want to analyze each layer. Well, you do that with the simulated unstacker. You input your shape, and on the right it returns the top layer, and on the left it returns the rest. So you can chain this forward. The left side you can chain 3 times, or well 2 times, to get every layer. So as a result, you have the top layer here, the second layer, and the third layer. Yeah, actually 3 times. If you have 4 layers, you have a signal here too. So that's the simulated unstacker. Then it uses the simulated shape analyzer, which you can find on the right, and this building outputs the shape type and color of the northeast first layer quarter. Okay, big words, big words. If you have a compass here, it says the first northeast. Well, this is north. We're watching now north, and it outputs the shape type of that northeast quarter. In this shape, well, of course, it's a spike, the red spike. Well, would you look at that? It does return us a spike and the color red. This is the red spike that's on the northeast side. Then we want to continue analyzing the shape. Now we want the green spike, but we can't chain the shape analyzer because it will return the same thing. We need to rotate this signal so the green spike would be in the northeast position, which happens here. We rotate it, and lo and behold, we have the spike, green, the green spike. You do this 2 more times and you have the whole shape analyzed. And that's it. That's it. You have everything you need to make your shape. Then it's just a matter of copy pasting to the second layer, the third layer, and the fourth layer that I don't have. But so, like this, you have your full shape analyzed. If you wonder what, like crystals, let's do a 4th layer with crystals and pins. There you go. Remember, the simulated unstacker always does the top layer first. I added a 4th layer, so the 4th layer returns first. As you see here, we have 2 crystallized and 2 pins. It does work, but there is some exception with the pin. A pin does never have a color, which makes sense. It's a pin, it's always a placeholder of whatever. So remember that it doesn't display or sense any color signal. The crystal, on the other hand, does return a color. What do we have more? We have the simulated half destroyer. Well, what would it do? It simulates the half destroyer on the wire level. The input is this shape. You have destroyed it and you get this in return. Simple. just like the real building. Same for the stacker, for the painter, for the crystal generator, for the swapper, and for the pin pusher. The stacker now we've stacked this shape and this shape on top of each other, and you get this in return. The unstacker already covered. The simulated painter, well, sure, let's analyze this one. Then we use the painter. Yeah. You have two inputs, the color and the shape. You give it to the simulated painter and you get the painted shape in return. We want to swap. They are swapped. Let's say if you want to pin them after, you barely can see it. Yes, you can see some pins below. Well, this is just the simulated pin pusher. And that's basically everything about signals. If you have any questions whatsoever, don't hesitate to ask them in the comments. If I said something wrong, sure, correct me, because I've never talked so long for a video, for real. Even my mouth is dry of all the talking. But yeah, I hope that I answered some questions you had, and I want to thank you if you viewed the whole video until here. Well, a big thank you from me, because this was actually a very long, I think this is gonna be a long video. Anyway, thank you for watching. If you have questions, put them in the comments, and I'll see you next time.